Alright, so we got a physics problem here. A 5.1 kilogram box is on a frictionless slope of 37 degrees and is connected via massless string with a massless frictionless pulley to a hanging mass with 2.4 kilograms. And it is shown in figure 1, which is right here. What is the tension in the string if the 5.1 kilogram box is held in place so that it cannot move? So first we need to make sure we're doing the correct steps. So obviously step 0 is throw on music so that you don't go insane. And then step 1 is draw free body diagrams so that I can get all the forces set up correctly. So I'll do all of box 1 in blue. Let's just go and scroll down here. So box 1 is at an angle. So this way we're going to have tension. This way we're going to have the normal force. And then this way is going to be weight. And then this way is going to be nothing because we don't have gravity. Not gravity, we don't have friction. Which means that we need to split this into its x and y components. So in reality, what we have is tension, normal force, Wx, and Wy. And that's for box 1. That's all the forces acting on box 1. And then for box 2, that's going to be easier because we don't have a tilted coordinate system. So up we got tension, and down we have weight. There we go. That's all the forces acting on block 2. So step 2 is to write down your knowns for each box. I'll write that over here. Box 1. We know that mass of box 1 is equal to 5.1 kilograms. We know that theta is 37 degrees. We know that the weight force unsplit is going to be 5.1 Gs. We know that the Wx component, which is going to be this one right here, that's going to be the opposite. So if you were to draw the addition of vectors that make up W, is going to be the opposite side. So we know that that is going to be 5.1 G times sine of theta. I should just put 37 there. The y component is the adjacent, so it's 5.1 times gravity, and then we need the adjacent side, so that's cosine. That's a terrible theory, but who cares? We know the normal force is opposite the y side, so normal is equal to Wy. And we know that we also have a tension force, but that tension force is unknown. That's what we're solving for. So tension equals some number. And that's everything we know for box 1. Box 2. Oh, come on. Box 2 has a mass of 2.4 kilograms. And that means it has a weight force of 2.4 Gs. And we have an unknown tension force. And I guess I'll make this purple. And due to Newton's third law and how tensions work, these two tensions here are interchangeable. All right, so now that we have the knowns, step 3 is relate everything and figure out what we're trying to find. So we know acceleration is 0, which for both blocks, because both blocks are not moving, which means that the sum of all forces needs to equal 0. So we know the number we're trying to get to, so we're going to start doing some algebra. And we're going to be doing a lot of algebra. Right. So for algebra, I guess we'll do green. Come on. So let's start with block 2, because block 2 only has 2 forces acting on it. In order for it to be at equilibrium, come on. In order for it to be at equilibrium, its tension must equal its weight. And then for block 1, in order for it to be at equilibrium, we know that Wx needs to equal tension as well. So now that we see that both of these have to equal tension, we can set them equal to each other. Wait a minute. I did something wrong here. Step 4 is figure out what you did wrong. Oh, okay. So I think what I did wrong is I assumed acceleration was 0, when in reality it probably isn't 0. In reality, you probably have some amount of acceleration this way and some amount of acceleration this way. And if those accelerations are equal, then that means it doesn't move at all. Because you have equal amount of force pulling on both sides of the oh my gosh, of the pulley. So in reality, the formula I should be using is, oh, I didn't want to get rid of that line. Just that one. There we go. Oh. So step 5 is more algebra. That is a terrible writing. So for this box, in order to be, oh, okay. So Wx minus tension. Wait, no. Tension minus Wx is equal to W minus tension. Yes? Okay, you know what? I'm going to run with it. So 2t is equal to W plus Wx. So t would be W plus Wx divided by 2. So 2.4 26.8 newtons. That's completely wrong. Nice. Yeah. Not what I wanted. Step 6. Oh my gosh. Repeat steps 4 and 5. Wait, did I have acceleration pointing the wrong direction when I thought about this? Okay, so if you have acceleration pointing this way and acceleration pointing this way, that means that this one, weight, has to be greater. Weight is greater than tension. And this one also has to be, wait, x is greater than tension. Wx minus tension is equal to mass 1 times acceleration. And then W minus tension is equal to mass 2 times acceleration. Yes. So that means that Wx minus 1 a acceleration is equal to tension. And if that, then plug that in. So we get W minus Wx minus m1a equals m2a. So W minus Wx plus m1a is equal to m2a. W minus Wx divided by m2 minus m1 is equal to acceleration. Maybe. Okay, so W is 2.4 times 9.8 minus 5.1 times sine of 37 divided by 2.4 minus 5.1 negative 7.57. Oh, I forgot to multiply by g on the other one. .429. Okay. So now that I know acceleration, I can just plug it into either one. So let's just go over here. Wx, actually this one is easier. So let's just do W minus m2a equals tension. So that would be 2.4 times 9.8 minus 2.4 times the acceleration, 17.8 newtons. Okay, that's also wrong. let's go. I think I'm on the right track with the other one, though. What am I thinking? So the sum of forces in the x direction. That is not the notation. Oh my gosh. Sum of forces in the x direction, which is equal to, I'm assuming positive is this way, so it would be tension minus Wx. And the sum of forces in this x direction at a 1, 2 is equal to W minus tension. That means they'll have different accelerations. But the forces acting against this string are going to be the same. And that means they'll cancel out? Maybe. Wait, did I already do this method? Oh my gosh, I'm losing it. I think I already did this method. Or did I not do this method? Plug in tension, so M2A is equal to W2 M1A plus WX M2. Yeah, I got different signs on the last one. Acceleration is equal to, well, W2 minus WX divided by the sum of the masses. Makes more sense. Okay. So W2 is the 2.4 times the 9.8. And then WX is which one? 0.1 times 9.8 times sine of 37. And then divided by the sum of the masses, 5.1 plus 2.4. Negative, I guess. Negative 0.7. A, I guess. That makes sense there. Doesn't make sense there. run with it. 5.1 times the acceleration plus 9.8 times sine 37 times 5.1. 25.6. Okay. That's also wrong. There has to be some part of my approach that's completely wrong. Okay. Do I even need to solve acceleration? Oh, wait a minute. Wait a minute. Okay, so if I'm assuming I'm basing off of this. The acceleration down is that way, but this one's gonna have negative acceleration. So that means that tension, or yeah, Wx minus tension is equal to mass 1 times negative acceleration. Because it needs to, the acceleration needs to point this way, and this one, the acceleration is still positive. So this would be W minus tension is equal to m2 times acceleration, because that is positive. Yes. Okay, let's run with this again. So we have Wx plus m1 times acceleration is equal to tension, because that negative sign goes there, and so you add it, add, okay. Didn't I already do this? This is going to be a plus. Yeah, I already did this one. Oh, but I didn't plug it into the equation right. Okay. $25.6. Did I already answer 25.6? I feel like I did. I did. Okay. Bro. All right. Step 7. Cry in a corner. Okay, maybe this entire philosophy is just wrong. Step 8, Google. Um, do I need to do the acceleration of the entire system? What? Okay, okay. Apparently the answer was do this in orange. Yeah. Tension. What is the tension of the string if the held in place so that it cannot move? Oh. 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 I completely misread that question. Oh my gosh. It's held in place. So there's more outside forces. There's like a hand right here grabbing it and like holding it there. And since it's holding it there, it's adding extra force, which means this has to be in if this isn't moving, this can't be moving either. There's other forces that we don't know, which means that the tension has to be the same as this. That way this stays the same. So that way tension is literally just tension is just weight 2. So tension is just 23.52 newtons. And this is the correct answer. And there's 2 more parts to this. Okay, yeah. Oh, oh, come on. All right, and then step 9 is realize you are dumb. 10. Get the answer. Good half of it. Okay, now we repeat the steps with part B. Just throw here, I guess. When the box is released, which way will it move on the slope? So we know tension is 23.52 newtons. And so we can just find the x and see if it's greater than. It's gonna move downward. And that's correct. So it's gonna move downward because you look at the free body diagram and stuff. See that the only thing, tension is gonna remain the same. Tension is the same because that's the tension if this wasn't moving. So that means the only other force you need to figure out is this, and this is about 30. So it's, nope, no, I don't want it. This is about 30 newtons. And 30 is obviously bigger than 23.52. What is the tension in the string once the box begins to move? Okay. So once it begins to move, this. Okay, wait a minute. Did I already do the math for this? It's gonna be 30. Let me just. Okay. Man, I was about to say. Anyways, now this math that I did before is going to come in useful. At least the theory behind it. Okay, I'll do this problem's math in black. So Wx minus tension is equal to mass 1 times acceleration. I'm going to assume positive is this way because it's going to be going in that direction. And then tension minus W2 is equal to M2 times acceleration. So that means that tension is equal to M2 plus W2. Plug that in over here. Wx minus M2A plus W2 equals M1A, which is some number. Wx minus M2A minus W2 is equal to M1A. Algebra Wx, whoa. Wx minus W2 divided by the sum of the masses is equal to the acceleration. So that would be the 5.1 times 9.8 times sine of 37 minus 2.4 times 9.8. And that divided by the sum of the masses. I swear if I get the same acceleration from before, I'm going to shoot someone. But I shouldn't. I do. Okay. Okay. It's fine. Everything's fine. Everything is fine. .4 times that plus 2.4 times 9.8. $25.6. Please be right. 12 please be right. Yes! Oh. Okay, so now that I had an acceleration, I could take the acceleration and plug it in over here for tension. So it would be M2A plus W2, and that is equal to 25.6 newtons. And that's the correct answer. And that's the homework problem complete. Oh my gosh. Okay. How many more do I have of these? 5. Oh man. Okay, there you go. These are the engineering steps right here. This is how physicists do problems.